All right, example 1 says an unbalanced system of two, or is an unbalanced system of two objects. So the diagram shows two masses, mass 1 and mass 2, connected via a string across two frictionless pulleys. The masses are initially held in place and then they're allowed to freely move. If mass 1 is 4.7 kilograms and mass 2 is 1.8 kilograms, the first thing they want to know is which direction will the masses accelerate. All right, so mass 1 is 4.7 kilograms. Mass 2 is 1.8 kilograms. So 4.7 is heavier than 1.8. So because this is heavier, the masses will accelerate towards mass 1, meaning mass 2 is going to accelerate up and over. I guess I could draw a better arrow. Mass 1 is going to go down. So these are our accelerations. The next thing we need to do is draw the free body diagram, or the force diagram for each mass. So we've got mass 1, so I'm going to draw my square. This is mass 1, and it weighs 4.7 kilograms. We know that the force of gravity is pulling down on it. So I can say the force of gravity for this first one down here, and we know the force of gravity is equal to the mass times the gravity. And then the force of tension is pulling it up. And we don't know what that force of tension is right now. All right, and then we're going to have our cute little free body, our force diagram for number 2. So this is our second mass. It's M2, and it's 1.8 kilograms. We know that the force of gravity is also pulling this one down. So the force of gravity of 2 is equal to the mass of 2 times gravity. And we know the force of tension is holding it up. For both of these diagrams, let's label which way our acceleration is going. So on this first one, over here, we said in part A that it was going to accelerate down. So acceleration is down, so down is going to be positive and up is going to be negative. For this second one, acceleration is up, so up is going to be positive and down is going to be negative. And it's a good practice to always base the positive direction for each mass and the direction of acceleration. So you want the positive direction in the direction of acceleration. All right, and that's all there is to part B. Part C wants us to determine the magnitude of acceleration of the masses. All right. The first thing we need to know is all of the forces that are acting on this very first mass. So for M1, we need to know all the forces. So our force net of M1 is equal to, there's only two forces working here, the force of gravity 1 and the force of tension. All right. I can say that my net force, or because of Newton's laws, I can say that the net force is equal to the mass of 1 times acceleration. And we said that down was positive, So the force of G1 is equal to the mass of 1 times gravity. Going upwards is negative, and we don't know what this force of tension is equal to. So I'm going to set this as negative force of tension. And I'm going to stop right there. I can't simplify this any further. So let's do the same thing for our second mass. So mass 2. For mass 2, our net forces is what we need to look at first. So our net forces are the force of gravity on object 2 and the force of tension. Because of Newton, I can say that my net force is the mass of 2 times the acceleration. And I'm going to flip these around because force of tension is positive here, and I can't break that down any further. So I'm going to put force of tension here. This is going to be a negative minus M2G. All right, when I'm looking at these, I can't break any of these down any further. But I notice that both of them have this force of tension. So what I'm going to do is I'm going to solve one of these for force of tension. And I want to get rid of this negative force of tension here. So I'm going to solve this one for force of tension. So I'm going to say the force of tension is equal to mass 1 gravity minus mass 1 acceleration. Now I can take this part and plug it in here. So my final equation is going to look like this. I'll have mass 2 acceleration equals mass 1 gravity minus mass 1 acceleration minus mass 2 gravity. All right, we can, if we wanted to, solve this entire thing right here for A. But I've noticed in class, a lot of y'all like to go ahead and plug in the numbers and then work it. That's a little bit easier for you. I'm going to plug in the numbers right here without units. But if you do what I do, you need to make sure that you remember to include units and include proper units in your answer. I don't advise this, but it'll make it a little bit easier to see. So my mass 2 is 1.8 kilograms. And I don't know what acceleration is. That's equal to mass 1 times gravity. So mass 1 is 4.7. Gravity is 9.8 minus mass 1 acceleration. Mass 1 is 4.7, and we don't know what acceleration is. Mass 2 is 1.8. Gravity is 9.8. All right. And now all I need to do is solve for A. I'm going to start with my multiplication first. So I'm going to get 1.8A equals 46.06 minus 4.7A minus 17.64. I'm going to collect my like terms. So 4.7A plus 1.8A equals 46.06 minus 17.64. So 6.5A is equal to 28.5 0.42. So A is equal to 4.372. So my acceleration is going to be 4.372 meters per second squared. The last thing it asks us to solve for up here is the force of tension in the string. So to solve for the force of tension in the string, I need to find an equation I've already made that solves or looks for force of tension, and I have one right here. So I'm going to say, I'll change colors, I guess, to make it a little easier to see the difference, if I can find a different color. I'm going to say the force of tension is equal to M1G minus M1A. So my force of tension is equal to, my first mass is 4.7, gravity is 9.8, minus 4.7 times, we just said acceleration was 4.372. So my force of tension is going to come out to be 25.51 newtons. So all there is left to do on this problem right now is to write my therefore statement. We've solved for everything it asked for. So my therefore statement will say, therefore, the masses of acceleration with a magnitude I'm sorry, I don't know what I'm writing. The masses will accelerate with a at 4.372 meters per second squared with a tension force in the string of 25.51 newtons. Mass 1 will accelerate down. Mass 2 will accelerate up. And there's our statement.